Onyx, I might have got it working. What if I can have my video? Hi, Onyx. Twinkie, you're gross. I don't know why I can't get my video feed to show up. Can you guys hear me? Miller, can you hear me? Hi, Andrew. Robert Andrew, can you hear me? There's like a 10 or 15 second delay, which is typical, but for some reason I can't get my video to show up, like from my webcam. Hallelujah! Okay. Well, if you guys have questions, feel free to ask. This is the best way I can answer them while you guys are not with me. So, because I can draw things and answer questions. At least I can try. I have 3 dogs on the bed with me, so if you hear something weird, I'm sorry. If I do this anywhere else in the house, though, they kind of freak out and then start barking and fussing at me. And Onyx has a cold. That's disgusting. Well, here, I'm going to start drawing pictures until people ask me questions. I'm sorry this took so long, guys. I've never had this many problems getting this system to work before. I'm going to call my husband up to see if he can fix the webcam, because he's been able to do that for me before and I don't remember what he did last time. So I'm going to try and mute the audio so you guys don't have to hear me scream, and if that doesn't work, I'm really sorry. Alright, hopefully you guys didn't have to just hear me screaming. Let's see. Did we go anything relating to Exam 1, Question 10? We have not done Newman projections yet. We will do those for Exam 2. For Exam 1, I finally got up and working, honey. For Exam 1, I had chapters 1, 2, 3, and I think a little bit of 4 on the first exam, just because the summer's really accelerated. But we haven't done that yet. So if you see something on there that doesn't look anything like anything we've done, just skip over it and you'll do it on the next exam. Alright. Let's see if you can help me get my video up, because you helped me do it last time.
Mm-hmm.
And I remember there were some settings. Video capture. And so like my webcam light comes on, but it's not showing up.
Let's see.
I had to turn it on the 34-bit instead of the 64-bit. I don't know why. But it's still showing up as 64-bit. Mr. Spelta, could you please tell me what question 6 says on the summer exam? I kind of don't have it in front of me. Believe it or not, I don't memorize every question to every exam.
Custom FPS style, and then you change the resolution.
Okay.
What's the resolution you need?
What do you have? It's fine. That's great. Okay. I like a little square box. Thank you, honey. Onyx, say hi to the kids. Okay. All right. Now I'm cooking with fire. It's so weird. Okay. So hopefully now you can see me and hear me and see visual of everything. If not, I'm really sorry. This looks like it's about as good as I'm going to be able to do. But
when you, before you turn it off for the night, take pictures of all the settings.
Okay. PKA predicting using size chart. Okay, yeah. So let me pull this up real quick. You guys have to bear with me because to do this I have to have about 45 different windows open. Okay, so if I have something, for example, like we could do this using 2 different molecules, okay, ones that are very similar. So let's put one up here with a nitrogen, and then let's put one here with an oxygen, okay. Can I make that bigger? Let me make that a little bit bigger. Okay, so if we're looking at these 2 molecules, we could look at these in 2 different ways. I could say, for example, what would be, which molecule would you expect to be more acidic and why? You know the pKa values, so you already have kind of a guide to go off of, but me asking things like that is basically asking to justify the pKa that you would expect to see. Okay, so for example, if I have the molecule on the left, which is an amine, right? It has an NH2 group on it. I could say, okay, why would that amine have a pKa up in the 30s? Okay, compared to carbon, which would be like up in the 50s, or compared to oxygen, the alcohols, which are down like around 16 to 18. So why basically would a base, a really good base, want to be able to pull off that hydrogen from the nitrogen? And so there are a couple of things that we could say. Well, nitrogen is electronegative. Okay, it is not a rather large atom. So the guide I gave you guys in class is if it's below period 2, like the things that would have d orbital electrons in them, we'll consider it kind of small. Okay. And so we wouldn't have any kind of size issue with that. There's no charge on the nitrogen that would be relieved. There's no resonance. This is not a benzene ring, it's just cyclohexane, so there's no double bonds to have resonance. There's no inductive effects, etc. And now if I asked the same thing over here, oxygen is electronegative. Okay. Now we know that there's more than one type of question I can ask out of this, right? I mean, I could say something like, why would this be rather acidic? Why would this be rather acidic? But I could also ask, why would one be more acidic than the other? So let's say that we're looking at the oxygen. We know the pKa for alcohols is around 16 to 18. Sorry, my dog's nails are clicking all over the floor. Oxygen is electronegative, pKa is 16 to 18. The nitrogen's electronegative, but the pKa is closer to somewhere in the 30s. Okay, and for amines, it kind of varies pretty widely on the rest of the molecule. That's why I don't have like a small range like I do for the alcohols. So another question I could ask, in addition to just justifying which of those 5 factors would contribute to acidity of these 2 molecules, the other thing would be, why would the oxygen be more acidic than the nitrogen? So if we were looking at that, there's still no resonance involved, right? You're looking at a comparison. So Andrew, do you have like an idea on why the oxygen having a hydrogen on it would be more acidic than the nitrogen? I'll give you 10 seconds to think about it, and then I'll answer because there's a delay. Okay, so if you think about oxygen, it's way more electronegative than nitrogen, right? It's further to the left, further to the right on the periodic table. So if you're looking at comparing 2 molecules, you can think about things like electronegativity, things like size, okay? They're kind of additive effects, right? If you think about the halo acids, like hydrofluoric acid all the way down to hydroiodic acid, the iodine, none of those have inductive effects, none of them have resonance, none of them have charge, but they're all some level of electronegative, and the ones that are further down, especially things like iodine, are very, very large, okay? And so because it's so large, it's going to be able to handle a charge better if you're looking at hydroiodic acid compared to something like hydrofluoric acid. And that's why hydrofluoric acid, even though it is very electronegative, it's going to be in actually the weak acid category. Its pKa is greater than 0. Does that answer your question? I'm hoping you can still hear me and that I'm not just randomly talking and you guys can't hear anything I'm saying. Okay, good. Did that answer your question? I'm hoping that made sense. There's really 2 main types of questions that I usually ask that are kind of thought questions like that, and it's usually explain why one of these would be fairly acidic, or comparing 2 things, and why would one be more acidic than the other. Twinkie. Twinkie. Got it out. My dogs are being gross, I'm sorry. Hey Miller, can you get in touch with Delkus and let her know that I'm able to make this work right now? That would be spectacular if you could do that. In the meantime, I will do another example. All right. So here's a question for you, Robert. Just a second. Gotta draw things up for you. Okay. Oh, okay. Well, thank you, Miller. I appreciate it. But in the meantime, guys, look at this molecule here. I want you to think about it for a few seconds. It's obviously easier for me to do these online than for you to respond via text, but I want you to look at this and think, what would be the most acidic hydrogen on the molecule I just drew? If you did it out as the Kekula or the Lewis dot structure, you would see that there are, let's see, 1, 2, 3, 4, 5, 7 hydrogens. So which of those would be considered the most acidic hydrogen, and what factors of the 5 that we've talked about would contribute to its low pKa value? Diana is also getting ready to join on board. She was sending me an email, so. Okay. Yes, Andrew, it would be on the oxygen. And we know that because you've memorized the pKa number line, right? There's no hydrogen on the chlorine to come off, right? It's connected directly to a carbon. And we know that carbons aren't particularly acidic, right? We've memorized that fact. And so the question is, why is it out of those 7 hydrogens, the one on the oxygen would be the most acidic, the most willing to donate that hydrogen if there was a strong enough base present, okay? So let me put this down and we can come up with a list. So if I were to take off, just a second, where's my arrow button? There it is. Come on, little buddy. There we go. Okay, so this is essentially what we're looking at, right? So let's think about those 5 factors. So Andrew, you said oxygen stabilizes the charge. Yes, it does so through electronegativity, right? So the more electronegative an atom, the more willing it is to accept those negatively charged particles, the electrons, so that having extra negative on it is not really a bad thing. So yes, we will write down on our list electronegativity. If I can pull up my text box. All right. What else? Did I relieve a charge when I deprotonated the oxygen? The answer is no. So for charge, I'm just going to put an X there and say nope. What about resonance? Are there any kind of resonance contributors that would be able to basically spread that charge out and share it amongst different atoms? The answer to that one is yes. So if I moved in, this is kind of hard to do when I don't have it set up, but I can move my electrons in there. Just a second. Okay. And then these electrons would then move out. Just swap that. Sorry, it takes a little bit of time to do mechanisms on ChemSketch. And then we could have one more where it comes out on that last carbon, which would give us a whole different structure, right? We could actually have 2 resonance structures, one where that first electron, or those electrons from the oxygen move in, and then kick those electrons onto that carbon there in the middle, and then the other one where it kind of goes all the way out to the end. So resonance would definitely be a contributing factor to making this more acidic. And then, do we have any inductive effects? Well, to look for inductive effects, you just look to see if there's any kind of electronegative atom somewhere downwind on the molecule that's not part of the acid-base chemistry. And in this case, we have a chlorine. So things that you would look for would be things that you would consider electronegative. Fluorine, chlorine, bromine, oxygen, nitrogen. Those would be the kinds of atoms you would look at for inductive effects. And then, let's see, what's my last one? Size. Well, as we said, oxygen's not particularly large, and that's what we're having to look at because that's where the hydrogen's coming off. So for size, I'm going to put a big fat X there because oxygen's not going to really be able to contribute to stabilizing this negative charge based on its size, but it will based off its electronegativity. So there is another example for you. Somebody asked me another question. Let me see if... As everybody keeps emailing me questions, I'm having to email them back and say, hey, it's finally working now. Go online. Okay. So I'm going to just kind of scroll down on this a little bit, make a little bit more room. Remove that right there. Okay. And then let me... Okay, Diana sent me a question saying, can I explain the pKa values to the scale and the scale? So yeah, Diana, I covered a little bit of that before I got your email. So what you're really looking for is, you know, the pKa, you're talking about the acidity constant, right? The ability of something to donate a proton. The number, the lower it is the better it is able to donate that hydrogen, meaning it's a better acid. So that's why all of our strong acids are below 0 on the number line. They completely ionize and donate all their hydrogens. Whereas something that's above the 0 line, which is pretty much almost all of our organic molecules, those are not going to be able to donate a hydrogen as easy unless there's a really strong base present, okay? So a very strong acid doesn't need a very strong base to react. It could react with a very weak base, but a very, very strong base can react with even a very weak acid. So it's all kind of relative, which is why I keep saying acid and base chemistry is very, very relative, okay? So the number line I give you guys is just so you guys can have a couple of structures based off their functional groups anchored in your mind, so you have a good idea of where different types of functional groups are, depending on where the hydrogens are on the molecule, basically. And then the next day, after we covered kind of learning where those are, we learned about those 5 different factors that contribute to why those pKa values would be low on one molecule or high on another molecule, okay? The reason that this is important is because a lot of the chemistry that we do is actually just proton transfers, acid-base reactions, okay? It's the simplest of the types of reactions that we do, so it's important to understand where it comes from. And it's also very, very important in biochemistry. Your amino acids do about 98% acid-base chemistry, as indicated by the name amino acid. So that's the reason that we need to go over it and learn it really well. But we have those 5 factors that all contribute to making a pKa lower. Okay, so if you look at the really strong acids, things like sulfuric acid, nitric acid, those are going to have basically all 5 factors that we've talked about in going for it, basically. If you looked at things like hydroiodic acid compared to hydrofluoric acid, it makes sense that the hydroiodic acid has a pKa in like -9 range, whereas hydrofluoric acid's a little bit higher, like over 1 basically in the weak acid range, because hydroiodic acid, the hydrogen's attached to a very, very, very large atom, iodine. Okay, we know that size is an important factor. So essentially what we've had to do is memorize a couple of numbers on a number line so that we have a general idea of where other things will fall. Obviously, there's different functional groups we haven't covered, and they run the gamut, the whole spectrum. And then if you are interested in understanding why they're there, which is what I'm trying to get you to do, you're going to see certain contributing factors that are going to push the pKa one direction or the other, okay? So hopefully, if you are watching this at some point soon and you hear me, this makes sense to you. If not, please feel free to ask me more questions. Janae sent me a question saying, when drawing isomers, does the type of structure matter, or should we just keep it consistent with one type? I think what she's meaning by that, I'm not positive, but it sounds like she's wondering if I care if you draw it as a skeletal structure or a Lewis dot structure, calculus structure, condensed structure, or some combination of both. I don't care. I'll say that in class multiple times throughout the semester. I do expect if I said draw a calculus structure of this or a skeletal structure of this molecule, I would expect that you can do that. Okay, so it's important to me to know that you guys can kind of navigate the different types of structures that we use in organic chemistry. But as far as answering questions, if I don't specify anything, I don't care. Draw whatever's going to help you understand it better and get the better chance of getting correct answers. If you need to see all those carbons, that's fine. And I'll hand out scrap paper tomorrow with you guys so that if you need it, you can use it. I think that probably answers her question. So, Miller, Andrew, you are the only two that I see still on the chat logs. Did you guys have any other questions? I'm still sitting here. Here, I'll give us some Twinkie Jam in a second. Everybody wants a Twinkie. Twinkie. What you doing, Twinkie? He's so silly. Miller has met Twinkie before, I think. Andrew, you have not. He's a Corgi Husky mix, so he's a very large dog with very, very short legs and has some severe mobility issues because of it. He's very special. Twinkie is amazing. And that's okay if you don't have any specific questions. I mean, it always helps just to hear what other people are asking. Sometimes it's like, oh, yeah, I guess I did have that question and I didn't realize it. So, you know, that's perfectly fine. Andrew is... I was going to say, is that in reference to my dog or something else? Yeah, Twinkie is amazing. Let's find it up here. Hey, Twinkie, come here. Come here. You're famous. Come here. Get on the internet. Come on. Twinkie, come here. Okay, you too, Red. Come on. Okay. So now I have Red. Come here, Red. This is Red Dog. Red Dog, answer chemistry questions. Red Dog is very large. He's as big as me. Size, head size for scale. Yeah, I try and bring at least one or two of the dogs for study day, so Last semester I actually brought, I think I brought red, and we had like a potluck and study day on the Thursday before finals. I'm happy to do it as long as I don't have anyone in class who's either allergic to or terrified of dogs. Yeah, Andrew, Red is the red monster. He's about 110 pounds. He's a very, very large dog, so... Red's digging his nose into the blanket and, like, snorting on me. Okay. Quick question. What's that called? I'm going to drill you guys if nobody's asking questions. You have me for another few minutes, so... Give you a couple structures. Close. What's the difference between pentane and cyclopentane, Miller? There you go. Make sure you keep the cyclic in there if it's cyclic. Rudder, what are you doing? Yes. And then what's the other one? There's one with 11 carbons. So this one here is 1, 2, 3, 4, 5, 6 hexane. That's right, you got it this time. And then the other one's got 11. 2, 4, 6, 8, 10, 11. So what's 11 carbons called? Undecane. Yeah, it's actually like the same prefix as like uno, 1. Dos, dodecane, 2. It's actually very similar to the first couple numbers in Spanish. My mother, the Spanish teacher, would be proud of me right now. Okay. Let me scroll on down to another one. Alright. There's 4 carbons, it's butane. Can you think of an isomer for that molecule? There's only one. I wouldn't expect you to name it on the test tomorrow. We did cover how to name it in class on Friday, but you could probably think about it and describe it to yourselves. So if you're looking at this and thinking, okay, there's 4 carbons, right? That's kind of a good place to start if you're thinking about let's see. If you're thinking of isomers, 3, 4, 5, 6, 7, 9, 10. Okay. And so for me, if I'm thinking of something that's an isomer and it has no units of unsaturation, then I just come up with different ways to stick the carbons together. So for me, I could say, okay, so instead of sticking it 4 in a row, I could stick 1 in the middle. And that would be C4H10. So that's an isomer of that other butane. Now we wouldn't call this butane, even though it's 4 carbons, because we reserve the name butane for 4 carbons in a row. So we'll talk more about it, but this one we would call that methyl propane, because it's a propane, 3 carbons, with a methyl group on carbon 2, so 2-methyl propane. Trying to see if I got any more. I think I'm good on the emails. And it looks like it's still just the 2 of you guys. It says 3 watching, and it includes me because I keep the channel up. So if you don't have any other questions, then I'll let you guys go and finish your studying and things. If you have any other questions, let me know. I'm glad that we were able to get this working, at least for a little bit tonight. We've actually been streaming now for a while. Yeah, 40 minutes. Red, nobody wants to hear you licking your feet. You're so stupid. Come here. Oh, my dog is special. 3 of them. Oh, I didn't know. I thought that it did start live. I did not know that it started from the beginning. I don't know. There's like a 10 to 15 second delay, which I guess is, it's unavoidable just because it takes a while for information to move. You're funny. Okay. Well, if you guys don't need anything else, then I think I'm going to hop off and go take a shower and things like that. But if you still have any other questions, you can hit me up with email tonight. I'll have to come in tomorrow a couple minutes early because I have to print off the exam. But you're welcome. Glad it finally got through. I'm sorry about the technical difficulties. It was horrible trying to figure that out. I was on their online forums and stuff, and those guys are like super IT geniuses. And girls, I have no idea what their gender is, but they're just like, well, what is the blah 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 doing? I'm like, I don't know. So I'm glad we got it working though. So I'll see you guys in the morning. And if you talk to anyone, you know, let them know that we talked about acid-base chemistry and things like that. A couple naming questions and some acid-base problems. So I'll see you guys in the morning with bells on.